Hi everyone, welcome back to Java 1 for All. Let's continue the unit tests topic, and I'm going to show you test coverage for now. So imagine that we have our test here. Well, don't have to imagine, do have your test here, but let's say that we would like to test the coverage of this test. Right click and then run person service test with coverage, and you will notice that we will get a menu here, coverage. And basically it's telling, usually coverage is for the whole project, but since we are just starting with tests now, we only have test coverage for this person service class. Basically, if you take a look at this, looks perfect because you have one class being tested 100%, the methods are 100% tested, and the lines are 100% coverage. Well, it looks very good. If you go back to the person service, you will see that the coverage is passing through all the code that we have inside is adult. But I ask you, do you think this is enough? If you take a look at the is adult, basically we are not doing anything that we should be doing. For example, we do not test if the person actually is adult when it returns true. We don't test, for example, if the exception being from here is the exact type that we say that it is. For example, this one is going to return no pointer. We should check for that. Maybe it's not important for this project, but if you are working in a web project and usually you have different HTTP status, for example, 400 bad requests, 404 not found, 500 internal server error, and that is important for the front end because basically the message that the front end is going to show to the end user may be different based on the status code, the exception that you are returning to them. So let's fix the test now that we know that coverage is not everything because we have 100%, but we're not testing not even like 50% of what we should be doing. So person service test, I'm going to, oh, not this test, and I'm going to copy this, including the test annotation, display name, and a person should be adult if older than 18. So basically, I'm testing the other way around now, and it should return actually older or equals 18 because 18 should be included. So is adult, return true when age is greater or equal than 18. And here we put 18. And now, instead of assert false, we are going to assert that this condition is adult is true. So Control Shift F10. And now we have two tests. If you run the entire class, you will see now that we have more tests. Basically, should not be adult and should be adult if older or equals 18. But if you take a look here, it looks like we are duplicating our code. Unit tests should be independent. So the fact that you are changing something here, you could change the person's age, should not affect the next unit test. So that is a better way for us to do this, and is using the at before each. So basically, when we use this annotation inside over a method, it means that this method setup, it could be any name, will be executed each time a unit test is going to start. So what I want to do, I want to create a person and a person service. So basically, I will create here person adult, not adult, and then person service. And before each test, I would like adult to be a new person 18 years old. Not adult, I will just add $15, and service, person service will be new person service. So what's the difference of having the before each and having it initialized here? Basically, if you initialize here, you have a class attribute. So any changes you do in one of your tests, it will affect all the tests. Now here, every time you have a test, it will be executed. So you will have a new object per test. And now we can just remove here, and here we have not adult. And then you remove here, and here you have adult. Now you can execute everything to make sure that your tests are still working. You are testing the test. And now we are imagining a scenario where someone else came to your code and they decided, well, looks like the law is going to change, and now the person dot get age should be adult when they are greater or equals 21 years old. Now, if you execute, so let's say that someone else came and they changed it, and they would just run the test and see if this change is going to affect something, and you can see that one of the tests failed. So basically, you are expecting the test to be adult when the age is actually equal or greater than 18. So what does this mean? This means that maybe somewhere else in the project or some other system was expecting the same thing. In this case, it's important for whoever is changing to go and check if this is actually true. Sometimes you are not actually going to affect any other service or maybe not even other classes, but there are some cases where one change may even affect something related to the law. So it's important for you that are making the change to make sure that first you are updating the tests, because if it's something required, you have to make sure that the tests are updated, and you have to check everything else that the test sometimes it's not covering or is actually covering. So it's quite tricky because unit testing means that you are testing that specific piece of code. And if that code is affecting other systems, would be part of the integration tests. So other systems should expect the age to be 18 as well, to be considered adult. And if that breaks, and then you have to update not only your system, but all the other systems. So you can see the chain starts growing, and it's quite difficult to keep track with everything, even though you have tests. So let's go back and just keep 18. Now, the other thing that we need to test is deception. So as I said, sometimes you are working with front-end, and front-end is expecting the exception to be one specific exception. In this case, it doesn't make a lot of sense, but for example, front-end sometimes works with HTTP status. 400 is a bad request, 404 resource not found, 500 internal server error. And that's important because the way the message is going to be displayed to the end user may change based on the exception that they receive. So it's good for you to check the exception and make sure that you are working with the exception that was defined in agreement with the whole team. So to test this required no, I'm going to copy this test. And basically, I will say here, is adult should throw no pointer exception when person is no. And then is adult throw no pointer exception when person is no. And now, how should we write the assertion? So we have one specific assertion here from jUnit that is assert throws. So basically we're expecting a no pointer exception, and this no pointer exception should be coming from the person service is adult when I just send a new object. And then I can even say here a message. A person can't be null. Let me press enter here. There you go. So this message is what is going to be displayed in case it fails. So let's check it out. Let's write like this. And the method is adult. So Control Shift F10. And as you can see, it's working. But let's imagine that, for example, someone doesn't like null pointer exception and they come here. Okay, so I don't like null pointer exception that much. I will make sure that we are throwing illegal argument exception because, well, it looks better. We are going to remove this and then actually Shift F10 or just press here. And the test now it's failing. So a person can be null, unexpected exception type. So we were expecting null pointer exception, but what it's coming now is illegal argument exception. So that could or could not affect the other systems, the front end in this case. But if it's not affecting, we just have to change here to illegal argument exception and then execute the code again. Now going back to the person service, let's imagine that we have a method that will filter if we're going to filter all the people that's not adult from the list and return a list with only adult person. So public, we are going to return a list of person. And then filter removing not adult. And then we are receiving a list of person. And then return person list string filter. This is adult. Collectors collect to list. Now we go back to the person service test and we are going to copy this method. So basically the should remove all non-adult people from list. And then we can call the method here, copy the filter removing non-adult, remove non-adults from list when list with person is passed. That looks big, but when you have access only to the terminal, the better and more descriptive the methods your tests are. Actually, in this case, it doesn't matter because we're using display name, the better. So assertions, assert rows, actually now we are going to change. There are a couple ways you can solve this one. For example, you can create here 3 people. Person 1, let's say that this one, you could still reuse the ones that we have here, or you could create them. I'm just showing you an alternative way. Let's say you have one here with 17 years old, and then person 2, it's 18, and person 3 is 21. And then you have here a list of person with person 1, person 2, and then person 3. Now, how can you test this? So you have a couple options. For example, you could create another list with only the expected result. The expected result would be person 2 and 3. And then you have a search where you can compare two lists. And let's say that we pass this list and we are expecting another list as return. Or just a little bit more simple way, let's say that assertions.assert equals, and what I'm going to assert, I know that I have 3 people. From these 3 people, only 2 are adults. So it basically means that I have to have a person list back with size 2. So person list, actually first is expected 2, and then person service, then filter, passing the list that I created here, and the size should be 2. Why? Because 18 will keep these two guys in this list that we are removing here. So Control Shift F10, and as you can see, it's working. Every once in a while, it's good for you to test the whole class, because otherwise you are fixing one test and break another one. So we can see that we have 4 tests, and now if we go back to the same thing we did before, and now okay, the age is 21, and we execute Shift F10, you have now 2 tests failing. So you can see how one small change can start affecting your entire system. So we have 2 methods now failing. One, that we should have adult, in this case here, or when they are older or equal to 18 years old. And another one, it should remove all known adult people from the list. So basically, this is how unit tests they work. You write your test, and then you write your method, and then you create a test with the expected result. And if something changes in the business logic, definitely it's going to fail, and it's up to you if you have to update the test or maybe revert your original changes. Now, there are one thing here that we didn't, actually 2 things. One, about private methods. Honestly, I don't test private methods because you cannot access private methods in your test. Usually, if you have a private method, you have a public method calling. So technically, you kind of test as a side effect. And methods that are returning or not returning anything. The return is void. In this case, it's quite difficult for you to test. I think one of the only ways to do it is if you have some logs, and then you have to check if some logs are returned or displayed in the console. But usually, if you have returns, it makes it easier for you to test, or maybe just check if nothing happens, no exception is from. So there are different ways to do it, but the general idea about unit testing you already have. Now, with a quick research, you can go ahead and figure out how to do the rest. But since we still have more topics now, from now on, for the rest, we are going to talk about the topic, and then we are going to use unit tests to validate what we have been doing. So I hope you enjoyed. See you in the next video. Bye bye.